Imagine a universe that never forgets, a cosmos where every whisper, every heartbeat, every fleeting breath still trembles somewhere in the dark, suspended in the folds of space-time. What if nothing is truly lost? What if every moment you've ever lived, every thought that ever flickered across your mind, still lingers, encoded within the silent architecture of the universe itself? In this haunting expanse, time is not a river that flows and disappears. It is an ocean, vast, still, and layered with every second that has ever been. Beneath its surface, the first light of creation still glows. The echoes of ancient stars still murmur, and the traces of every life still drift, undissolved. The equations of physics whisper that energy cannot be destroyed, that information cannot vanish. Every motion, every sound, every breath leaves a signature in the invisible geometry of existence. Even as stars collapse and galaxies fade into entropy, those signatures remain, faint, immortal, embedded in the curvature of space-time. So what if this universe, this vast, silent observer, remembers everything? What if the warmth of your life, the spark of your consciousness, is never erased but simply transformed, scattered like starlight across eternity, somewhere beyond the edge of sight, in the stillness between galaxies? The record of your existence continues, unbroken, immutable, eternal. And as the darkness deepens, one question remains, quiet but inescapable. If time never dies, do we? Before there were stars, before light or shadow, before anything could move or change or exist, there was no before. There was no ticking, no rhythm, no unfolding sequence of events. The universe was timeless, a still void without memory or motion. Then, in a single incomprehensible instant, the silence fractured. Energy erupted from nothingness, and with it, the first moment was born. This was the Big Bang. Not merely an explosion in space, but the birth of space itself. And entwined within that newborn expanse came the first thread of time. Time began as a fragile current flowing through the chaos, a dimension intertwined with space, forming the fabric that would cradle every atom, every star, every future. In the first trillionth of a second, matter and radiation surged through this new reality, sculpting the first directions, up, down, forward, and back, and a single, irreversible flow, the march from past to future. But time was not something separate, ticking outside the cosmos. It was embedded within the very geometry of the universe, inseparable from its shape, its energy, and its destiny. Einstein would one day reveal this truth through the language of relativity. Space and time, he showed, are not distinct arenas, but two faces of the same continuum, space-time, where every motion, every force, every orbit is a story written on a four-dimensional canvas. Mass bends this canvas, and in doing so, it bends time itself. Where gravity is strong, time slows. Where the void is open and empty, it races ahead. The ticking of clocks and the beating of hearts are not universal. They are local performances, each following the rhythm dictated by the geometry around them. In this cosmic design, time does not simply pass, it is sculpted. Every galaxy spins within its own temporal landscape, each second unfolding at a slightly different pace. The flow of time is not absolute as Newton once imagined. It is elastic, curved by matter, molded by energy. The universe measures existence through this subtle interplay of gravity and geometry. Every change is recorded as a distortion in the fabric, every event an indentation that will never fully fade. But what does it mean for time to be born? If time began at the Big Bang, then asking what came before is like asking what lies north of the North Pole. The word itself loses meaning. The laws that govern existence were themselves created in that first instant, leaving no frame of reference beyond it. This is the edge of comprehension, where physics becomes philosophy and science reaches into the void for meaning. As the infant universe expanded, its temperature plummeted. Within seconds, fundamental forces separated. Gravity first, then the strong nuclear force, then electromagnetism and the weak force. Each separation defined a new layer of structure, a new way for matter to behave. Time moved forward through these transitions, marking an irreversible sequence. Symmetry breaking, particle formation, the birth of light. This unfolding sequence, the simple fact that one event followed another, became the universe's first language of memory. Causality emerged. One thing could now lead to another. The universe had learned to tell stories, to remember the past, and anticipate the future. Every collision, every fusion, every quantum vibration became a sentence in an expanding cosmic narrative. Out of randomness, order began to take root, guided by the gentle hand of physical law. Time became not only the measure of motion, but the reason motion could exist at all. Without it, there would be no cause and no effect, no structure and no decay, no birth and no death. Billions of years later, human minds would awaken within this ordered chaos and wonder, if time began once, could it end? And if it has direction, what gives it purpose? The search for answers led back to Einstein's revelation that time and space are inseparable, but also finite. Together, they form a continuum that stretches, folds, and curves, but may not last forever. The cosmos may be expanding, but its timeline is written within the same fabric, and every expansion carries an echo of that first, primal unfolding, the moment when existence itself began to remember. The philosophical weight of this truth is immense. If time is a dimension like space, then the past is not gone. It still exists, frozen somewhere within the structure of the universe, as real as the present moment we now inhabit. The Big Bang did not just ignite creation, it etched the first coordinate on an eternal map. The birth of time was not the start of motion alone, but the formation of a cosmic architecture in which every instant is preserved. In this view, the universe is not a river flowing forward, but a landscape, static, vast, and complete. Every moment, from the birth of the first atom to the death of the last star, exists simultaneously, woven into the four-dimensional tapestry of space-time. We perceive motion because our consciousness travels through this landscape, frame by frame, creating the illusion of passage. But to the universe itself, all moments coexist: the infant cosmos and the dying one, the first light and the final darkness. This is the essence of the block universe, a reality without true beginnings or endings, only coordinates in the grand architecture of existence. Time in this vision does not destroy, it simply reveals. Every heartbeat, every flicker of light, every fleeting second is inscribed forever in the geometry of space-time, neither lost nor erased, only unseen by those who move through it. Thus, when cosmologists speak of the birth of time, they speak not of a ticking clock, but of the awakening of memory itself, the moment the universe gained the ability to remember that it exists. From that single spark, all history unfolded, each instant becoming another thread in the infinite weave. And though the stars will one day fade, the imprint of their light, like every heartbeat, every thought, every breath, will remain, written forever in the silent structure that began in that first impossible moment. When time was born, the universe remembers, not through words or thoughts or stories, but through light, through the faint and endless shimmer of energy that has been traveling across the cosmic void since the dawn of existence. In its silence, the universe has kept everything, every flicker, every collision, every death of a star, preserved in the invisible patterns that stretch through space-time. To gaze into the night sky is not to see the present, but to witness an ancient record, a living archive of what once was. It began with a question that haunted physics for generations. Does the universe forget? If stars burn out and galaxies die, does their memory fade into nothing? Or does the fabric of reality keep a trace of their passing? The first clue came from the mathematics of a man who saw time not as a flow, but as a structure, Albert Einstein. Einstein's general theory of relativity revealed that space and time are not the passive stage on which events unfold, but an active participant in the drama. Mass and energy curve space-time, and in doing so, they leave behind an imprint, a signature of their presence. Every planet, every particle, every motion carves a subtle mark into the geometry of the universe. This curvature is more than gravity, it is memory. Even when the matter moves on, the space-time it disturbed continues to ripple, recording that something once passed this way. These ripples, known today as gravitational waves, are the faintest whispers of cosmic history. When black holes collide or neutron stars merge, they send vibrations through space-time itself, like echoes in an infinite sea. Billions of years later, those waves reach Earth, where delicate instruments such as LIGO and Virgo listen for their arrival. Each detection is a recovered memory, a fragment of an event so distant that it occurred before the Earth even formed. But long before humanity could hear these whispers, it had already seen the light of the universe's first memory. In 1965, Arno Penzias and Robert Wilson, working with a radio antenna in New Jersey, detected a strange, persistent noise. It came from every direction in the sky, unchanging and eternal. At first, they thought it was interference, perhaps pigeon droppings on the antenna. But it was not interference, it was the faint glow of the birth of time itself. This discovery became known as the cosmic microwave background, the afterglow of the Big Bang. It is the oldest light in existence, a remnant from when the universe was only 380,000 years old. In that moment, the hot plasma of the early cosmos cooled enough for light to finally travel freely through space. The photons released then have been traveling ever since, carrying with them the temperature, density, and structure of that primordial age. Every tiny fluctuation in that ancient radiation tells a story of how galaxies would one day form, how gravity would weave stars into spirals, how emptiness and matter would dance into the pattern of everything we now see. The cosmic background is not just light, it is a map of the universe's first memory, preserved in the faintest microwaves that still hum around us. When scientists at NASA and ESA created images of this radiation through satellites like COBE, WMAP, and Planck, they were, for the first time, looking at the face of the infant universe, a photograph older than any star. Those photons, stretched and cooled by the universe's expansion, still bathe the cosmos today at a temperature just 2.7 degrees above absolute zero. They are everywhere, in every direction, in every corner of the night sky. Each one carries the memory of a time when there were no stars, no galaxies, no boundaries between light and matter. The universe itself was the memory, glowing faintly with the story of its own creation. Light became the great messenger of time. Every photon that escapes a star carries within it a record, a final message of the conditions, temperature, and motion of the surface it left behind. These photons travel at the speed of light, crossing billions of years of expanding space. When they reach a distant observer, they bring with them the past, unaltered. What we see in the night sky is not the present state of things, but the preserved image of how they once were. The Andromeda galaxy that glows faintly in the night sky is not the Andromeda that exists now, but the one that shone 2.5 million years ago, when early humans first stood upright on Earth. The light from the Pleiades cluster left those stars before the pyramids of Egypt were built. The faint radiance from the most distant galaxies observed by the James Webb Space Telescope began its journey more than 13 billion years ago, when the first stars in existence ignited. Each photon, an ancient traveler, carries a message from an age we can never return to. A record written not on paper, but in the structure of space-time itself. Space, then, is not emptiness. It is an archive. It holds within it the electromagnetic signatures, gravitational waves, and quantum echoes of every event that has ever happened. Even when matter decays, energy disperses, or stars collapse, their influence lingers in the curvature of space-time, in the quiet distortions that define the geometry of the universe. This is how the cosmos remembers, not through preservation of form, but through the indelible memory of interaction. Each star that dies leaves a scar of gravity that reshapes its surroundings. Each planet that moves alters the space-time through which it travels. Even a single photon passing between galaxies exerts a faint influence, bending, scattering, or redshifting as it passes through clouds of dark matter. The universe records all of it, endlessly, silently, perfectly. Modern cosmology now views this memory as fundamental. The universe's expansion itself carries evidence of its past. The accelerating growth of space, first discovered through the observation of distant supernovae in the 1990s, tells a story of a cosmos dominated not by matter, but by an unseen force, dark energy. The pattern of this acceleration, encoded in the distribution of galaxies and the polarization of ancient light, gives clues to how memory may be stored on a cosmic scale. The geometry of the universe holds the imprint of everything that has shaped it. Even on the smallest scales, the idea of universal memory persists. Quantum mechanics teaches that information cannot be destroyed. Every particle interaction, every quantum fluctuation, leaves behind a trace, an entangled echo that cannot truly vanish. The universe, by its own laws, refuses to forget. This principle lies at the heart of the black hole information paradox, where physicists like Stephen Hawking, Leonard Susskind, and Juan Maldacena have sought to understand how information escapes from what seems like oblivion. Their work suggests that the fabric of spacetime itself may encode every event, ensuring that even the most catastrophic cosmic collapse leaves its signature written somewhere in the geometry of the whole. This realization reshaped the way scientists and philosophers view the night sky. The darkness between stars is not empty. It is filled with radiation, particles, and gravitational whispers that together form the most complete memory system imaginable. Every direction we look is a different page in a universal record book. To study astronomy is not to look outward, but backward, through time. Each observation is an act of remembrance. When the Hubble Space Telescope was pointed at what seemed to be an empty patch of sky in 1995, it revealed thousands of galaxies in that darkness. What appeared empty was, in truth, saturated with history, with light that had traveled for billions of years to reach us. The image became known as the Hubble Deep Field, a testament to the universe's relentless capacity to remember. And now, with the James Webb Space Telescope, humanity peers even deeper, capturing light that began its journey when the first atoms came together. In every pixel of its images lies a story older than our species, older than our planet, older than time as we experience it. These photons, unbroken through billions of years of expansion, are fragments of memory, a cosmic diary still unfolding. Thus, the universe stands revealed as the grandest memory engine in existence. Its light does not simply illuminate, it recalls. Its shadows do not conceal, they archive. Every glimmer of a distant star is an ancient message, carried through oceans of time and darkness, whispering what once was. The night sky is not darkness at all, it is remembrance. Every point of light is a moment, a truth, a memory still alive. The universe has never forgotten where it came from, because forgetting is impossible when every atom, every photon, every ripple of gravity carries the mark of what has been. And as the cosmos continues to expand, its archive grows ever larger, an infinite record written across eternity. The stars may fade, galaxies may dissolve, but the memory of their light will continue to move through the void, a silent hymn to the fact that in this universe, nothing is ever truly lost, only remembered forever in the language of light. In the silence of the cosmic expanse, time moves with an unwavering direction, always forward, never back. Every sunrise follows night, every breath follows the last, every star that burns must one day fade into coldness. Yet the laws of physics, the fundamental equations that describe the universe, do not demand such direction. They work equally well when time runs in reverse. Gravity would still pull, quantum waves would still oscillate, and the equations of motion would still hold true. Nothing in the mathematics of nature requires the future to be different from the past. And yet, it is. This mystery, the one that defines existence itself, rests upon a single, haunting principle: entropy. In the late 19th century, an Austrian physicist named Ludwig Boltzmann saw something extraordinary in the behavior of matter. Beneath the swirling chaos of gases and the steady tick of clocks, he found a hidden order, the statistical rhythm of countless particles moving through time. He realized that nature tends toward disorder, not because of destruction, but because disorder is simply more probable. The universe, he suggested, moves from low entropy to high entropy because that is the way of numbers, of chance, of nature itself. Entropy is not chaos in the poetic sense, but a measure of information, of how many ways matter can arrange itself while still appearing the same on a larger scale. A deck of cards perfectly ordered can exist in only one configuration. Shuffle it, and it can exist in trillions. Entropy rises because the universe naturally drifts towards these countless possibilities, spreading its energy and information across wider and wider states. This law, the second law of thermodynamics, became the foundation of time's arrow. It states that in any closed system, entropy never decreases. Energy spreads, heat flows from hot to cold, stars burn their fuel and collapse, ice melts, mountains crumble. Everything moves toward equilibrium, toward uniformity, toward the end of distinction. It is this irreversible unfolding that gives time its meaning. In the earliest moments after the Big Bang, the universe was impossibly hot and dense, yet astonishingly ordered, a low entropy beginning that physics cannot yet fully explain. From that improbable starting point, entropy has been climbing ever since, driving the expansion of the cosmos, the formation of stars, and the birth of life. Every act of creation, from the ignition of a star to the spark of thought in a human brain, feeds on the difference between order and disorder. It is the very imbalance that allows existence to unfold. But there is a paradox at the heart of this law. The equations governing atoms, light, and gravity are time-symmetric. They do not care which direction time moves. If a video of colliding particles were played backward, the mathematics would describe it perfectly. Yet on the scale of life, of heat and decay, the world moves in only one direction. A glass shatters but never reassembles. Smoke rises but never returns to the flame. Entropy grows, and with it, time marches forward. Boltzmann understood this asymmetry as a matter of probability. The universe, he said, began in an extraordinarily improbable state of low entropy, and its movement toward disorder is the most likely path it could take. But this answer raises a deeper question. Why was the universe ever ordered in the first place? Why did the cosmos begin in such an improbable condition? This question, known as the past hypothesis, remains one of the deepest unsolved riddles in physics. Modern cosmology suggests that gravity itself may hold the key. In a young, dense universe, matter was spread almost evenly, a state that looks ordered to human eyes but was, gravitationally, the most unstable state possible. Gravity, always seeking collapse and clustering, drives the formation of stars, galaxies, and black holes, increasing complexity even as entropy continues to rise. In this way, disorder gives birth to structure. Entropy, the great destroyer, also becomes the architect of beauty. The arrow of time is therefore not a simple march toward decay, but a cosmic dance of transformation. Stars burn to create heavier elements. Those elements form planets. Planets form life. Every act of becoming is accompanied by a greater act of dispersal. The heat that powers a star also escapes into the cold. The light that fuels life on Earth also radiates into space, lost forever. Entropy measures the cost of creation. At the human scale, entropy defines memory itself. To remember an event, a system must change. Neurons must fire, patterns must form, energy must be used and dissipated. Memory is irreversible. Once written, it alters the structure of the brain, increasing entropy while preserving the trace of what once occurred. This dual nature, destruction birthing record, lies at the core of time's mystery. Entropy does not just erase, it also remembers, encoding the irreversible nature of each event into the geometry of existence. In this sense, every act of entropy is a form of recording. A footprint pressed into sand, a fossilized bone, the cooling of a dying star, all are physical imprints of processes that cannot be undone. The arrow of time writes itself into matter. The universe remembers through the scars it carries. Yet some physicists ask whether this direction is an illusion, born not of the universe, but of perception. To an observer within spacetime, entropy appears to increase. But from a higher, timeless perspective, one in which all events coexist in the block universe, there is no flow at all. All states, from low entropy to high, simply exist as coordinates in the grand tapestry of space-time. The sense of passage may be a product of consciousness, an emergent experience created by a mind that perceives change within the static whole. Still, entropy's arrow governs everything from the decay of matter to the expansion of galaxies. It defines the rhythm of cosmic evolution, the heat death of the universe, a theoretical future when all usable energy is spent and entropy reaches its maximum, stands as the ultimate expression of this law. In that distant age, there will be no gradients left to drive motion, no stars to burn, no patterns to sustain. Time, as measured by change, will lose its meaning. The universe will become a silent equilibrium, uniform, eternal, unchanging. Yet even this final stillness may not be the end of memory. Quantum mechanics tells us that information cannot be destroyed, only transformed. Even as entropy rises, the details of what once was remain encoded in the structure of the whole, perhaps in subtle quantum correlations, perhaps in the curvature of space-time itself. If so, the final state of maximum entropy would not be empty oblivion, but the perfect archive of everything that ever occurred. Entropy, then, is both the arrow and the archivist of time. It propels the universe toward the future while engraving every moment into its structure. Each irreversible act, each collapse, each decay, each breath leaves a trace that cannot be undone. The rise of entropy is the unfolding of history itself. The arrow of time points forward because the universe remembers only one direction. It is the direction of loss, but also of creation. The path from simplicity to complexity, from symmetry to story. And when all that remains is equilibrium, when time's arrow fades into the horizon of stillness, the memory of its passage will still exist, hidden in the quiet geometry of what remains. In this way, entropy is not the destroyer of meaning, but its source. Without it, there would be no motion, no memory, no cause, and no effect. Only the frozen perfection of timelessness. Entropy is the heartbeat of becoming. It is the universe's way of remembering that it once was. In the vast stillness between galaxies, where light travels for billions of years without interruption, there lies a truth more profound than distance. The universe does not forget. Every motion, every collision, every flicker of light leaves its imprint upon the very fabric of reality. The cosmos remembers, and its memory is woven not in ink or sound, but in the geometry of space-time itself. Einstein revealed this secret more than a century ago when he redefined gravity. What humanity once thought of as a force pulling objects together became, in his vision, the bending of space and the flow of time. Matter and energy did not merely exist in space. They sculpted it. A star curves the fabric around it. A planet glides along that curve, and the path it takes, its trajectory, its story, becomes part of space-time's shape. Every mass that has ever moved, every photon that has ever passed, leaves behind a subtle distortion in the cosmic fabric. In this way, the universe carries a silent archive of everything that has occurred. When great events unfold, when neutron stars collide, when black holes merge, the universe trembles. Gravitational waves ripple outward at the speed of light, stretching and squeezing space as they go. Detected first in 2015 by the LIGO observatories, these waves are the faint whispers of cosmic violence, carrying the memory of ancient catastrophes across billions of years. They are not sound, but the motion of space-time itself, the trembling of reality, remembering its own upheaval. Each gravitational wave is a message written in the structure of the universe, a wave that cannot be erased, only diluted as it spreads. In this way, the cosmos behaves like a vast ocean, where every splash, every disturbance, sends ripples that eventually fade into calm, but never truly vanish. The memory of the movement remains imprinted in the pattern of the sea. At the quantum scale, this recording becomes even more mysterious. Quantum theory tells that information, the fundamental description of any particle's state, can never be destroyed. It can change, transform, disperse, but it cannot vanish. Even when particles interact and become entangled, even when systems appear to collapse into randomness, their information is not lost. It is hidden, spread across the entangled web of the universe. This process, known as quantum decoherence, ensures that reality itself functions as a perfect ledger. Not one that stores each detail neatly, but one that embeds them everywhere, smeared across existence in a pattern that only the cosmos can read. This idea reaches its most haunting form in the riddle of black holes. When a star collapses under its own gravity, it forms an object so dense that not even light can escape. According to general relativity, everything that crosses a black hole's event horizon disappears from the observable universe. Yet quantum mechanics insists that information cannot be destroyed. For decades, this conflict, known as the black hole information paradox, stood as one of the most profound puzzles in science. In the 1970s, Stephen Hawking revealed that black holes are not entirely black. They emit faint radiation, now called Hawking radiation, due to quantum effects near their horizons. Over unimaginable spans of time, this radiation causes black holes to evaporate, vanishing into nothingness. But if a black hole disappears, what happens to the information it swallowed? Is it erased from the universe? Or is it encoded somewhere beyond human understanding? Many physicists began to see black holes not as cosmic prisons, but as archives, mysterious hard drives storing the data of everything that ever fell within. The information, they argued, is preserved on the surface of the event horizon itself, etched into a thin, two-dimensional boundary that records three-dimensional events. From this idea arose one of the most radical theories in modern physics, the holographic principle. According to this principle, every volume of space, every region of the cosmos, could be described entirely by data encoded on its surface. The three-dimensional world humanity perceives may be a projection, a hologram, emerging from information inscribed on a distant cosmic boundary. In this view, the universe itself is the ultimate memory device, storing all events not within its depths, but upon its edges. The holographic principle finds mathematical support in string theory and in the study of black hole thermodynamics. The amount of information, or entropy, that a black hole can contain is proportional not to its volume, but to the area of its surface. This discovery shattered the traditional notion of where reality's information resides. It suggested that space and time, depth and distance, may all be emergent, illusions rising from a deeper informational layer, much as a three-dimensional image emerges from the encoded light on a holographic plate. If this is true, then every moment, every motion is inscribed somewhere in the fabric of reality. Every atom that burned in the first stars, every pulse of radiation that swept across the infant cosmos, every breath, every orbit, every fall, all are written into the structure of space-time. The universe does not erase, it only transforms. Even the background glow that fills the sky, the cosmic microwave background radiation, acts as a fossilized memory of creation. It is the afterglow of the Big Bang, stretched and cooled by cosmic expansion, carrying with it the imprint of the universe when it was only 380,000 years old. Its faint fluctuations record the earliest patterns of density that would one day grow into galaxies and clusters. The light we detect today has traveled for nearly 14 billion years to reach us. A message from the dawn of everything, preserved in the geometry of space. In this sense, space is not empty. It is an archive, a living tapestry woven from light, gravity, and quantum memory. When two galaxies collide, their stars rarely touch, yet their gravitational fields intertwine, distorting space-time and sending echoes through eternity. When matter falls into a black hole, its information is spread across the event horizon, recorded in the subtle vibration of the surface. And when the universe expands, it stretches not just space, but the very records within it, preserving every detail even as it grows colder and darker. Some theorists even suggest that reality itself is information, that matter, energy, and space-time are emergent phenomena arising from the quantum entanglement of bits of data. This idea, sometimes called it from bit, imagines the cosmos as a computational entity, a grand processing network where existence itself is the output of information exchange. In this framework, the laws of physics are not merely rules of motion, but algorithms of transformation. What we call memory, then, is not a feature of the universe. It is the universe. Black holes, gravitational waves, and the holographic horizon all point toward the same poetic truth. The cosmos is a storyteller that never stops writing. Every event leaves a mark. Every interaction ripples outward. The universe records itself through its own evolution. And though time may erase the forms of things, stars collapsing, civilizations fading, light dispersing into the void, the traces remain. They may be beyond recovery, buried in quantum noise or encoded in the horizon of space, but they are not gone. In the end, the universe itself may be the perfect historian, one that forgets nothing, even as it changes everything. The past is not lost. It is folded into the structure of the present. The curvature of space, the pattern of radiation, the shimmer of quantum entanglement, all are the handwriting of time. And when the last star fades, when the cosmos cools into silence, its story will not vanish. It will remain written in the invisible architecture of space-time, a vast, eternal memory of everything that ever was. In the quiet depths of the universe, where light bends and time slows, lies a question that terrifies even the most brilliant minds in physics. It is not about what exists, but about what remains. When something vanishes into darkness, when it is consumed by a black hole, does the universe remember it, or does it truly forget? This question gave birth to one of the most profound paradoxes in science, one that shook the foundations of modern physics and forced humanity to rethink what it means for reality to know itself. In the 1970s, Stephen Hawking, studying the quantum behavior of black holes, made a revelation that changed everything. According to Einstein's general relativity, nothing can escape the gravitational pull of a black hole once it crosses the event horizon. But quantum mechanics, the theory that governs the smallest scales of the universe, does not obey silence. It whispers that even in the blackest void, uncertainty never stops moving. Through subtle quantum effects near the event horizon, Hawking discovered that black holes are not truly black. They emit faint radiation, a slow, ghostly glow now known as Hawking radiation. This was not merely an academic discovery, it was a cosmic contradiction. If black holes radiate energy, they must eventually lose mass. And if they lose mass, they will, over unimaginable eons, evaporate completely, fading into nothing. But here lay the horror. What happens to everything that once fell inside? Every atom, every photon, every pattern of information that described a star, a planet, or a thought. Where does it go? According to classical physics, the answer was simple. It disappears. The black hole swallows not just matter, but the information describing it. Yet quantum theory forbids this. In the laws of quantum mechanics, information is sacred. The wave function, the mathematical description of a system's reality, evolves deterministically. It may change form, it may scatter and entangle, but it never vanishes. If information were lost, then the foundation of quantum physics would crumble. The universe would become a place of true randomness, where cause and effect could no longer be trusted. This conflict became known as the black hole information paradox. It was not just a debate about black holes. It was a war between two pillars of physics. Einstein's general relativity described gravity, space, and time with elegance. Quantum mechanics described energy, particles, and probabilities with unmatched precision. Both were proven true, yet together they refused to coexist peacefully. One said information could vanish. The other said it could not. Somewhere, one of them was lying. Or perhaps both were incomplete. For decades, the paradox haunted the scientific world. It was not merely a technical riddle, but an existential one. If the universe could forget, if information could be erased forever, then the arrow of time might not just flow forward, it might collapse. Reality itself would lose continuity. The past could be destroyed, and with it, the logic that connects every event to every consequence. The cosmos would be a machine that leaks truth, but some physicists refused to accept that nature could be so careless. Among them was Leonard Susskind, who became one of Hawking's most determined challengers. Susskind believed that Hawking's conclusion, that information disappears, violated something deeper than physics itself, the principle of unitarity, the rule that the total information in a closed system must remain constant. To preserve this law, he proposed something astonishing. Perhaps, he suggested, the information was never lost inside the black hole at all. Perhaps it was stored on its surface. This idea seemed impossible at first. The interior of a black hole contains three-dimensional space. Yet Susskind and other theorists, including Gerard 't Hooft and later Juan Maldacena, began to show that the information describing the interior could be encoded on a two-dimensional boundary, the event horizon. From this revelation grew the concept of holographic duality, the idea that every three-dimensional system might have an equivalent description on a two-dimensional surface, much like a hologram projects depth from flatness. Maldacena's work in the late 1990s provided the first mathematical evidence for this vision. In what became known as the ADS-CFT correspondence, he demonstrated a profound equivalence between two seemingly separate realms, a gravitational universe in a higher dimension and a quantum field theory existing on its lower dimensional boundary. Gravity and quantum mechanics were not enemies but mirrors. The paradox that divided them began to fade, replaced by a deeper unity, a cosmos that stores everything, everywhere. In this new vision, the black hole is not a destroyer, but a recorder. The information about everything that falls in, every vibration, every interaction, every quark and photon is spread thinly across its horizon, encoded in a way that no observer can yet decode, but that physics insists must exist. As the black hole emits Hawking radiation, that information leaks back into the universe, tangled and scrambled beyond recognition, but never truly gone. This was the triumph of information conservation, a realization that forgetting may be impossible in a perfect universe. Even when something appears to vanish, its echo remains hidden in the structure of reality. Every bit of data that ever existed continues to influence the quantum web, even when transformed beyond comprehension. Entanglement adds another layer to this cosmic memory. When two particles become entangled, their properties become inseparable. Measure one, and the other responds, no matter the distance between them. This connection defies classical understanding. It suggests that the universe operates not as a collection of independent objects, but as a single entangled system. Every particle shares a mirrored history with the rest of the cosmos, bound by invisible threads of quantum memory. This network of entanglement could, in theory, serve as the very mechanism by which information is preserved. As black holes emit radiation, quantum entanglement may weave the internal and external information together, maintaining the total sum of knowledge even as the whole evaporates. This concept gave rise to the ER-EPR conjecture, proposed by Maldacena and Susskind, suggesting that entanglement and wormholes, the bridges connecting distant regions of spacetime, may be two expressions of the same reality. The geometry of the universe itself could be built upon the fabric of quantum information. What emerges from this is not merely a scientific correction, but a philosophical revelation. Forgetting, in the deepest sense, might not exist. The universe appears to conserve not only matter and energy, but meaning. Every interaction, every collapse, every transformation leaves an imprint somewhere, in the curvature of space-time, in the correlations between particles, in the holographic code that underlies existence. Hawking himself eventually revised his stance. In the final years of his life, he acknowledged that information might indeed escape through subtle correlations in Hawking radiation. The paradox that had once threatened to tear physics apart began to find reconciliation, not through destruction of either theory, but through their unification in a higher understanding. And yet, even as the mathematics grows clearer, the mystery deepens. If every detail of reality is preserved, then what we call the past is not gone. It is encoded everywhere, in everything. The air, the light, the vacuum of space, all carry traces of what has been. The universe becomes not a sequence of moments, but a continuous act of remembrance. Perhaps this is why the cosmos feels eternal. Its expansion may stretch galaxies apart, its stars may fade, but the data of all that ever was remains inscribed in its invisible architecture. The laws of physics themselves ensure it. In this light, the black hole ceases to be a symbol of oblivion. It becomes the ultimate archivist, a cosmic vault that guards the universe's most secret memories. And in the same way, reality itself may be an endless act of conservation, where no truth is ever truly erased, only transformed. The paradox of information is more than a question of science. It is a mirror held up to existence, for if the universe cannot forget, then neither can we. The patterns that once were continue to echo, endlessly reflected through the structure of time. And somewhere, in the cold silence between the stars, the record of everything endures, unbroken, unforgotten, eternal, beneath the calm surface of space, beneath even the invisible fabric of space-time itself. There exists something deeper, a restless sea that never stands still. It is not made of stars or matter, but of possibilities, a quantum ocean that vibrates with every event, every interaction, every fleeting fluctuation that has ever occurred. This is the quantum field, the foundation of all things. And if the universe remembers, then this is where its memory begins. In modern physics, matter is no longer seen as solid, separate, or permanent. What appear to be particles, electrons, protons, photons, are not tiny dots drifting through emptiness. They are ripples, brief excitations within fields that stretch across the entire universe. Each kind of particle corresponds to its own field. The electron field, the photon field, the Higgs field. These fields are continuous, omnipresent, interwoven. They do not exist in space. They are space in its most fundamental form. When a particle is born, it is not created from nothing. It is a vibration, a localized disturbance in the underlying field. And when it interacts, collides, or decays, that interaction reshapes the field itself. Every fluctuation leaves a trace, an echo that propagates outward into the universal medium. In this way, the quantum field carries the history of everything that has ever happened within it. The field remembers. At the smallest scales, there is no emptiness. Even in the coldest vacuum, energy flickers in and out of existence. Virtual particles rise and vanish in moments too brief to measure. These fluctuations are not meaningless noise. They are the living heartbeat of the cosmos, the pulse of reality's memory at its deepest level. When two particles interact, they become entangled, their states forever linked. No matter how far apart they drift, their histories remain intertwined. Measure one, and the other responds, as if connected by an unseen thread woven through the very fabric of being. This entanglement is not just a curiosity. It is the fingerprint of a universe that does not forget. Each entangled pair carries a shared record of their encounter, written into their quantum states. Across billions of years and light years of separation, this invisible correlation persists. It is as if the universe itself insists on coherence, a grand bookkeeping system ensuring that no interaction, no event, is ever truly lost. Physicists describe this continuity through the mathematical language of wave functions, intricate patterns that describe the probabilities of where and how something might exist. These wave functions evolve smoothly and predictably according to Schrödinger's equation. But when a measurement occurs, when something is observed, the wave function appears to collapse, forcing a single outcome to emerge from a haze of possibilities. This collapse is one of the strangest moments in all of physics, a moment where uncertainty freezes into fact. Before the act of observation, a particle can exist in many states at once, spinning and not spinning, here and not here. But once observed, it must choose. The universe writes the outcome into its ledger. A decision has been made. Reality for an instant becomes definite. But what is this act of observation? Is it merely a physical interaction, or is it something more profound? In the quantum world, to observe is to participate, to exchange energy, to entangle, to influence the outcome. Each observation weaves new information into the cosmic field. The observer and the observed are not separate. They are co-authors of a shared history. From this view, the universe functions like an eternal recorder. Every interaction, every observation, every collapse of probability adds another entry into its quantum memory. The data is never erased. It becomes encoded in correlations, preserved in entanglement, stored within the field itself. Reality is not rebuilt anew each moment. It is updated like a vast evolving computation, one that remembers every calculation it has ever performed. In this sense, the arrow of time, the forward motion we experience, could be seen as the universe's way of recording. Each quantum event fixes one possibility out of many, locking it into history. The future remains fluid, but the past becomes immovable, not because it has faded, but because it has been written. Time, then, is the accumulation of choices made by the cosmos itself. The field view transforms the way humanity sees existence. There are no isolated particles, no independent moments. There is only one continuous field, one seamless whole, expressing itself through infinite vibrations. Every atom in a human body, every photon of light, every grain of dust drifting through a nebula is part of this grand, unbroken continuum. In this picture, individuality dissolves. What remains is connectivity, a universe where everything is related, everything influences, everything remembers. Some physicists and philosophers have begun to wonder whether consciousness itself could emerge from this ocean of interconnection. The brain, after all, is not a static structure, but a dynamic network of quantum and electrical interactions. If the universe is built upon quantum memory, could awareness be an expression of that same principle? A local ripple of the field becoming self-reflective? While science has yet to find a definitive answer, the question lingers at the edge of physics and philosophy. The theory of quantum cognition, though still speculative, explores the possibility that certain aspects of consciousness might involve quantum coherence, fleeting states where information is stored and processed in a way beyond classical limits. If this is true, then consciousness could be more than a biological phenomenon. It could be a manifestation of the universe's ability to remember itself. Yet even without invoking awareness, the quantum field remains the ultimate archive. It records not in words or symbols, but in structure and state. The electron orbiting an atom carries the memory of its previous interactions. The photons scattered from a star retain the signature of its temperature and motion. The cosmic microwave background still hums with the echoes of the universe's birth. Everything that exists carries its own story, written into its quantum properties. At its heart, the field is both medium and message, an endless sea of vibration where information never dies, only transforms. The act of existence is the act of remembrance. Every moment adds to the total wave function of the universe, a vast symphony of probabilities collapsing into reality one note at a time. Even time itself may be an emergent property of this memory, a byproduct of the field recording its changes. In the quantum equations, time is not a flow, but a coordinate, a relational measurement between events. The sense of motion, of past and future, may arise from the constant writing and rewriting of the universe's informational state. If so, the present is not a fleeting instant, but a boundary, the edge of the cosmic memory as it expands forward into the unknown. This vision reshapes the meaning of permanence. Nothing lasts forever, yet nothing is ever truly gone. The collapse of a wave function does not destroy potential, it merely transforms it. The death of a star feeds new elements into galaxies. The decay of a particle releases energy that continues the cosmic dance. Even the fading of matter into radiation carries forward the data of what once was. If the quantum field is the memory of the universe, then every atom, every photon, every thought is a page in its endless archive. Reality, from the smallest vibration to the largest structure, is an intricate web of remembrance, a network that stretches from the quantum to the cosmic. And perhaps, in some distant sense, when the universe contemplates itself, through the eyes of beings that wonder, through instruments that measure, through minds that seek, it is not learning something new, it is remembering. It is recalling its own structure, its own history, its own eternal presence. In the end, the quantum field is not just the foundation of matter or energy, it is the foundation of memory itself, a cosmic sea that records every ripple, every fluctuation, every spark of existence. And within that infinite depth, nothing is ever truly lost. Everything that has ever been remains, suspended in the quiet hum of the quantum world, a timeless, whispering remembrance of creation itself. In the vastness of the cosmos, time has always been the most elusive dimension, invisible, untouchable, yet inescapably real. Humanity measures it in ticking seconds and fading sunsets, but the universe itself may not count at all. For in the geometry of spacetime, there is no flow, no forward march. There is only structure. A grand, four-dimensional tapestry where every moment that has ever existed still resides, suspended like stars in an unchanging night. The theory of relativity shattered the comforting illusion of a universal now. Einstein's equations revealed that simultaneity, the simple notion that two events can occur at the same time, is an illusion born from limited perception. For one observer, two sparks may ignite together. For another, separated by motion or distance, one spark may precede the other. The fabric of space-time allows both truths to exist. There is no master clock ticking across the cosmos, no shared present moment that unites it all. Each observer carries their own rhythm of time, their own private slice of reality. In this view, past, present, and future are not fleeting stages of existence, but coordinates, fixed points in the landscape of the universe. Just as every mountain and valley already exists in a map of space, every moment already exists in the map of space-time. The train thought experiment that Einstein once imagined makes this strange truth tangible. A passenger on a swiftly moving train watches two bolts of lightning strike at opposite ends of the track. To her eyes, they happen simultaneously, but to the observer standing on the platform, one flash occurs before the other. Both are correct, for time itself bends with motion. The illusion of now dissolves into relativity. This revelation carries a quiet but unsettling consequence. If simultaneity is an illusion, then so too is the flow of time. The universe does not evolve from past to future, it simply is. Every event, the birth of a star, the collapse of a galaxy, the first cry of a newborn, the last breath of a dying sun, already occupies its place in space-time. From this higher perspective, nothing truly comes into being or fades away. All of it coexists, eternally etched into the geometry of reality. Physicists call this idea eternalism. In contrast to presentism, which claims only the now is real, eternalism envisions time as a vast block, a static, unchanging structure that contains every event that ever was or will be. This block universe does not flow or shift. Instead, consciousness moves through it, tracing a line from birth to death, much like a light beam crossing a crystal. What we call the passage of time may simply be the unfolding of awareness across an already written script. In this picture, the past has not vanished. It lies behind us, fixed and immutable. The future too is already woven into the fabric, invisible from our current vantage point, but real nonetheless. The feeling of change, the sensation that one moment gives birth to another, is a property of perception, not physics. Time does not pass. We pass through it. Einstein himself once wrote to the family of a lost friend that for those who understand physics, the distinction between past, present, and future is only a stubborn illusion. It was not a gesture of comfort. It was the recognition of a profound truth. In relativity, time is not a river. It is a landscape, and we are travelers moving through it, carried by the momentum of our existence. This view transforms every aspect of reality. The Big Bang, the formation of Earth, the rise of life, the slow cooling of stars, all are not sequential chapters, but simultaneous patterns within spacetime's frozen structure. From outside the block, every flicker of history stands still, glowing faintly within an eternal architecture. The arrow of time, the sense of direction from past to future, arises only because entropy increases within this structure, giving each observer a sense of irreversible flow. But the universe itself, viewed from beyond the arrow, remains timeless. In quantum mechanics, this tension deepens. The equations that describe fundamental particles contain no intrinsic time direction. They work just as well moving backward as forward. Time symmetry is built into the foundations of physics. Yet macroscopic experience, memory, decay, aging, insists upon a single direction. Entropy, the measure of disorder, provides the illusion of flow. We remember the past because it holds lower entropy than the present. The future, still unmeasured, contains countless possible arrangements, higher in disorder, waiting to unfold. But in the block universe, even this unfolding is pre-written. Every fluctuation, every quantum event already has its place. The idea unsettles human intuition because it removes the notion of becoming. If all moments coexist, then the universe does not happen. It simply is. The ticking of clocks and the beating of hearts are the same kind of motion that carries planets around stars. They trace paths through space-time, but they do not create time itself. A clock does not measure the flow of time. It measures the distance we move through it. And yet, this static vision of existence carries its own quiet beauty. If every moment remains forever real, then nothing is truly lost. The laughter of a child, the light of a star long extinguished, the fleeting warmth of a sunrise, all endure within the coordinates of space-time. Death does not erase, it merely seals the coordinates of a life completed. Somewhere in the block universe, each instant of existence still glows, unchanged and untouchable. Philosophers once argued that if the universe is eternal, meaning fixed in all its dimensions, then consciousness itself must be the true traveler. Awareness may be the motion that gives meaning to a still cosmos, the thread that experiences what the universe already contains. The sensation of time's flow might be the echo of consciousness moving across the structure of eternity, like a beam of light tracing the corridors of an infinite crystal. This perspective also invites a chilling question. If everything already exists, can change truly occur? Perhaps what we call change is the unfolding of a predetermined geometry, the reading of a cosmic manuscript that has already been written. Free will from within the block becomes the experience of walking through the path, unaware that it has been paved since the beginning. But from within that illusion lies meaning, for it is in the experience of motion, of choice, of uncertainty, that consciousness finds itself alive. The theory of relativity thus transforms time from a flowing current into a mirror, one that reflects not just the structure of the universe, but the nature of existence itself. It reveals a cosmos where every life, every era, every atom's vibration is permanently embedded in the geometry of being. There is no before or after. There is only the eternal is. And yet, within this eternity, motion persists. Stars explode, galaxies drift, lives begin and end. Though time may not flow, the illusion of flow gives birth to history, memory, and meaning. It allows awareness to traverse the infinite tapestry, to see itself as moving forward through something that, in truth, has already been. If eternalism is right, then each of us is a line in space-time, a curve that begins, bends and fades but never disappears. Every breath, every heartbeat, every moment of joy or sorrow still exists somewhere in that vast geometry. The universe holds it all in silent symmetry, a perfect record of being, and so the paradox resolves itself in quiet stillness. Time does not pass, we do. The universe does not change. It contains all change within itself. We are not swept forward by the current of time. We are the current, flowing through a sea that has never moved. And in that timeless mirror, Existence gazes back at itself, forever whole, forever now. Across the silent ocean of the cosmos, a question lingers in the cold. Does the universe remember? If the past is never lost, where is it kept? And in what form does the cosmos hold its history? In the vastness of existence, every particle, every beam of light, every gravitational tremor might be a whisper from what once was. The universe is not only expanding, it is remembering, encoding its own story into the very architecture of space. 400,000 years after the Big Bang, the newborn universe exhaled its first light. That faint glow, now stretched and cooled by billions of years of cosmic expansion, still surrounds everything. The cosmic microwave background. Invisible to human eyes, it drifts through the void like an ancient photograph, the oldest surviving image of existence itself. Each pixel of this faint radiation carries within it the imprint of primordial ripples, tiny fluctuations in density that would one day become galaxies, stars, and life. It is the universe's first memory, a record not written in ink, but in radiation. When telescopes like Planck and WMAP mapped this cosmic afterglow, they uncovered a pattern older than time as we know it, a fingerprint of the beginning. The cold and warm patches are not random noise. They are the frozen remains of quantum fluctuations magnified by cosmic inflation, the echoes of microscopic vibrations in space-time itself. In their faint hum lies the memory of creation. The universe, in its infancy, preserved its own childhood through the language of light. But the cosmic memory did not stop there. As eons passed and gravity began its endless sculpting, the universe's memories took new forms. Galaxies formed like luminous neurons, connecting across cosmic filaments, vast strands of dark matter and gas stretching hundreds of millions of light years. These filaments form a structure eerily reminiscent of a mind, a cosmic brain whose nodes are clusters of galaxies and whose connections are gravitational highways. Through these threads, the universe records motion, mass, and momentum. Every galaxy orbiting within this web carries a history, the gravitational memory of all it has ever encountered. Einstein's general relativity ensures that nothing massive moves without leaving an imprint. The curvature of space-time bends, twists, and retains the scars of motion. Black holes ripple the very geometry with gravitational waves, faint tremors that travel outward, preserving the story of collisions that occurred billions of years ago. When instruments like LIGO or Virgo detect these waves, they are not hearing events as they happen. They are catching the echoes of a memory, space-time's own recollection of something unimaginably violent and ancient. The universe keeps its history not in books, but in its very shape. Even the light of stars is a messenger of memory. Every photon traveling across the void carries the moment of its birth imprinted in its wavelength. The light reaching Earth from distant galaxies began its journey long before humans existed. Some of it predates the formation of our planet, traversing billions of years and billions of miles, unchanged, untouched, unstoppable. When that light finally enters a telescope's lens, it collapses the gulf of eternity into a single instant. The act of observing becomes communion, the present touching the ancient. To look at the night sky is to read the universe's diary, written in photons instead of words. On the grandest scale, the universe functions like an archive, one that never erases. Gravity, light, and quantum fields all conspire to ensure that information, once created, never truly vanishes. Every motion alters spacetime's curvature. Every particle interaction leaves a trace in the quantum field. Every pulse of radiation carries the afterimage of what was. The cosmos is an enormous interconnected web of memory, its data stored not in silicon or paper, but in the fundamental structure of reality. And yet, within this grand architecture, the universe has birthed something remarkable: beings that remember. On one small planet, orbiting an ordinary star, matter began to organize itself into complex patterns. Life. Out of chemistry emerged consciousness, and with it came memory of a different kind. The human mind became the universe reflecting upon itself. With every photograph taken by a telescope, with every equation scribbled by a scientist, humanity expands the archive of existence. Each observation becomes a new layer in the cosmic memory, the universe recording itself through us. The Voyager probes, launched in the late 20th century, are perhaps the most poetic expression of this exchange. Tiny fragile emissaries of human curiosity, They now drift beyond the boundary of the solar system, carrying golden records etched with the sounds and images of Earth. Greetings in dozens of languages, music and the heartbeat of a species are encoded on a disk of gold, waiting in the dark. In cosmic terms, they are infinitesimal, but in meaning, they are infinite. They are humanity's attempt to be remembered by the stars. Each passing year, those probes move deeper into interstellar space, becoming part of the galactic archive. Long after Earth's continents shift, long after the sun grows cold, those small vessels will continue to drift, silent monuments of memory. In them, the universe preserves the story of its own awareness. For if humanity is born of stardust, then its artifacts are the stars remembering themselves. The symmetry is profound. Just as humans record the universe through images, data, and stories, the universe records humanity, embedding every photon emitted, every sound wave, every footprint into its expanding fabric. The exchange is endless. When telescopes capture the light of distant galaxies, the act of observation becomes a feedback loop. The observer and the observed become intertwined, each imprinting upon the other. The light that reaches our eyes alters our understanding, and that understanding changes the course of the species that perceives it. The cosmos watches itself through consciousness. In quantum mechanics, this idea gains deeper resonance. Every measurement, every observation, fixes a state, collapsing probability into memory. The act of perceiving does not merely witness the universe, it helps define it. Each observation adds another entry into the cosmic record, as though awareness itself participates in maintaining the archive. The boundary between observer and observed dissolves, and what remains is one continuous memory field, self-aware and eternal. Even silence is memory in the cosmos. The gaps between stars, the dark spaces between galaxies, hum with the faint residue of creation. Background neutrinos, ghostly particles that have traveled since the dawn of time, passing through planets and flesh without pause. These unseen messengers are memory incarnate, carrying the untouched chronology of the universe within their ghost-like passage. And so, the cosmos stands as a vast network of remembrance. From the ancient microwave glow that whispers of beginnings to the light of galaxies that recount aeons, to the human minds that capture and interpret the story. Every scale of existence, from the quantum to the cosmic, participates in the act of memory. Perhaps this is the ultimate symmetry, that in remembering, the universe sustains itself, that nothing truly vanishes, and every event, from the birth of a star to the thoughts of a mind, becomes part of a shared eternal record. When one looks up at the night sky, the darkness is not absence, it is presence. It is filled with the echoes of everything that has ever been, woven through the light, the fields, and the silence between. Every star that twinkles, every galaxy that glows faintly on the horizon, is not shining now, but then. The universe we see is a memory of itself, and somewhere within that endless archive drifting between the stars are the memories of a small world that once wondered what it meant to be remembered. In this exchange between cosmos and consciousness, between light and life, lies a quiet truth, that humans are not separate from the memory of the universe. They are its most recent entry. The universe remembers through radiation and gravity, through motion and mind. Its memory is not written in stone or sound, but in space-time itself. And in that grand ledger, every flicker of light, every breath of life, every question asked beneath the stars, remains forever inscribed. There is a silence at the edge of understanding, a border where science begins to resemble philosophy, and time itself begins to dissolve. Beyond the equations, beyond the ticking of clocks and the turning of galaxies, some physicists have begun to ask a question that trembles on the border of comprehension. What if time does not exist at all? What if everything that has ever happened, and everything that will ever happen, already is, suspended in an eternal stillness that only feels like motion, because consciousness moves through it like a dream? In this realm of thought stands Julian Barber, a physicist who dared to imagine a universe without time. According to his vision, the cosmos is not a movie that plays from beginning to end. It is a collection of countless individual frames, frozen nows, each existing independently, each as real as the next. He calls it Platonia, a landscape of moments, a vast gallery where every configuration of the universe exists simultaneously. To us, these snapshots seem to flow, but that flow may be nothing more than memory, a function of how one moment contains the trace of another. Barber's timeless physics proposes that motion, change and causality are illusions, emergent properties of how consciousness interprets a set of static configurations. What we perceive as the passage of time may simply be the unfolding of memory, the mind reading the sequence of universal stillness, frame by frame. In such a cosmos, the past is not gone and the future is not waiting. They simply are, side by side, woven into the geometry of existence itself. This idea finds strange companionship in one of theoretical physics' most enigmatic equations, the Wheeler-DeWitt equation. Formulated in the 1960s by John Archibald Wheeler and Bryce DeWitt, it attempts to describe the entire universe through quantum mechanics and general relativity combined. Yet in doing so, it reveals something unsettling. It has no time variable. Within its structure, the universe does not evolve. It simply exists. Time, as it appears to humans, is absent. The universe in this view is a static wave function, eternal, unchanging, infinite. This timeless view challenges the very foundation of experience. If the laws of physics at their deepest level contain no reference to time, then where does time emerge from? Some theorists suggest it might arise only when observers interact with the universe, when information is processed, when entropy increases, when memory differentiates one moment from another. In that sense, time may not be a universal property of nature, but a byproduct of consciousness itself, the way reality organizes experience into narrative. But the implications reach even further. The merging of quantum mechanics and relativity, the holy grail of modern physics, demands a new understanding of time. Quantum gravity, in its many formulations, treats spacetime not as a smooth, continuous fabric, but as something granular, composed of discrete informational units. Space and time could be quantized, broken into indivisible bits of reality. In this view, memory and spacetime may be one and the same, a network of informational nodes, encoding the structure of existence in every direction. The loop quantum gravity approach, for instance, envisions the universe as a vast web of loops, a mesh where geometry itself is woven from quantum threads. Within these loops, space and time are no longer background stages but active participants. The universe does not happen in time. It generates the illusion of time through its changing quantum relationships. If these theories hold, then time as humanity perceives it is a side effect of cosmic computation, a rhythm produced by the rearrangement of informational states. From this perspective, memory becomes the operating system of the universe. Each configuration of matter, energy, and field is not merely a physical state, but a line of code in a grand cosmic algorithm. The laws of physics are not commands imposed from above, but instructions written into the substrate of existence. Instructions that evolve not through time, but through relational change. To remember, then, is to compute, and to exist is to be stored in the universal memory that defines reality. The simulation hypothesis takes this analogy one step further. If reality is fundamentally informational, then perhaps it operates like a vast computational system. Every atom, every photon, every quantum fluctuation might be a data point, processed, rendered, and preserved by a deeper substrate beyond our perception. In this model, memory and spacetime are indistinguishable. The structure of space is the storage, and the unfolding of events is computation in motion. The passage of time becomes a perceptual trick, the system rendering one frame after another in an eternal program. Though speculative, such ideas force a profound reflection on the nature of experience. If all moments exist simultaneously, and if memory, not time, creates the sense of sequence, then death, birth, history, and destiny might all coexist as static regions in the vast informational landscape of the universe. Consciousness, in moving from one region to another, reads this landscape as a timeline. What appears as change is merely attention drifting through different configurations of being. Einstein's relativity already hinted at this. To him, the distinction between past, present, and future was a stubborn illusion, a trick of perception. The The equations of physics describe events, not flows. They define relationships between things, not their unfolding. And if those relationships are eternal, then perhaps the universe is not becoming, but simply is, forever. But even in this timeless vision, there remains beauty. For if all moments coexist, then nothing is ever truly lost. Every whisper of a supernova, every birth of a star, every thought, every love, every loss, all remain inscribed in the structure of reality. Memory is not just a feature of the human mind, it is the architecture of existence itself. The universe, in being timeless, becomes immortal. Physicists and philosophers now stand on this precipice together, searching for the boundary where mathematics meets meaning. They explore theories like causal set cosmology, where space-time is rebuilt from pure informational relationships, or emergent time frameworks, where entropy and information flow create the illusion of temporal order. Some even propose that consciousness is the mechanism by which timeless reality becomes self-aware, the bridge between static geometry and living narrative. At this speculative frontier, time, space, energy, and memory begin to merge into one concept, a unified field of being. The Wheeler-DeWitt equation, Barber's Platonia, quantum gravity, and digital simulation all whisper variations of the same haunting truth. Time may not be what flows, but what is read. The universe might not be moving forward. It might simply be there, whole, complete, eternal. And so perhaps time is not the river that carries existence forward, but the mirror that allows it to see itself. The illusion of sequence may be the only way the infinite can comprehend its own immensity, by unfolding eternity one remembered moment at a time. In this sense, the universe does not forget because it never needs to. It is all memory, boundless, silent, and complete. The ticking of clocks, the orbit of planets, the aging of stars. These are the stories consciousness tells to make sense of stillness. Beneath them all lies the truth that every instant of existence is already eternal, already written, already remembered. There is a quiet question hidden at the center of existence, a question whispered by decaying stars, dissolving worlds, and vanishing light. Can the universe truly forget? Or does every particle, every vibration, every breath ever taken remain inscribed somewhere in the silent geometry of space and time? The universe seems vast enough to contain eternity, yet fragile enough to lose its own memories to the slow tide of entropy. Somewhere between remembrance and oblivion, the cosmos struggles to hold on to itself. In the laws of physics, forgetting begins with entropy, the slow unraveling of order. In every thermodynamic process, in every star that burns its fuel, in every living thing that fades, entropy rises. It is the arrow of time, the one law that never reverses, a measure of how much information has dissolved into randomness. As entropy increases, the clarity of memory fades. Systems once bound in delicate patterns drift into noise. The universe, in its expansion, is slowly losing definition, like an ancient photograph bleached by cosmic light. Yet even as it decays, information cannot truly vanish, or so quantum mechanics insists. According to the principles of unitarity, the total information contained in a closed system is conserved, even if it becomes unrecognizable. This leads to one of physics' deepest paradoxes. If information can never be destroyed, what happens when it falls into a black hole? For decades, Stephen Hawking believed that black holes were the universe's ultimate forgetting machines, regions of space where all structure, all data, all traces of identity were swallowed and erased. According to his early calculations, black holes emit radiation, now known as Hawking radiation, and slowly evaporate over unimaginable timescales. But the radiation appeared to be purely thermal, carrying no trace of what had fallen in. If true, this would mean that information, once consumed by a black hole, was lost forever, violating the most sacred law of quantum theory. This became the black hole information paradox, a rift between general relativity and quantum mechanics, between the geometry of space and the arithmetic of information. For years, physicists struggled to reconcile the two, but near the end of his life, Hawking revised his stance. He proposed that black holes do release information, not lost, but scrambled beyond recognition. The surface of a black hole, its event horizon, may act as a kind of cosmic ledger, recording everything that falls in, then re-emitting it through subtle quantum fluctuations as the black hole evaporates. The universe, it seems, never truly forgets. It only encrypts. The information, though distorted beyond repair, lingers. Like a message translated through 1,000 imperfect languages, its meaning becomes impossible to read, but it remains, hidden within the noise of radiation. In this way, even the darkest voids of space participate in a strange kind of remembrance, where destruction itself becomes a form of preservation. The black hole does not erase the story. It folds it inward until only mathematics can trace its echo. This principle extends far beyond black holes. Every particle collision, every burst of energy, every fusion within a star creates and reshuffles information. When a supernova explodes, its atoms scatter across light years, yet their arrangement encodes a faint memory of the original structure. The dust that forms planets, the carbon that forms life, are the residue of stellar deaths, fragments of information reorganized into new forms. Forgetting in this sense is never absolute. It is transformation. Still, the universe trends toward forgetfulness. As it expands, energy spreads thinner, temperature drops, and motion slows. This progression leads toward the heat death of the universe, a time when all usable energy is evenly distributed, when no gradients remain to power stars, life, or memory. In that distant future, all that remains will be the faint afterglow of the cosmic microwave background, stretched to invisibility, and black holes quietly evaporating into nothing. Every atom will decay, every photon will redshift into oblivion. The cosmos will fall into perfect equilibrium, silent, dark, and still. Yet even this ultimate silence may not be final. The laws of mathematics whisper of recurrence, a concept known as the Poincaré recurrence theorem. It states that in a finite system with finite energy, given infinite time, every possible configuration will eventually repeat. Every galaxy, every life, every fleeting thought could, in principle, return. The universe, though it seems to dissolve, may one day remember itself. The timescales involved are beyond imagination, numbers with more zeros than atoms in existence, but the implication is profound. Forgetting, at the largest scale, might only be sleep. The cosmos could be caught in an endless loop of remembrance, eternally rediscovering its own past. The same patterns of matter and energy could emerge again, reshaped by entropy, but reborn in form. Memory then becomes cyclic, an infinite recurrence woven into the fabric of eternity. Still, between each recurrence lies an abyss of quiet, an era so long that no observer could endure to witness the return. The proton decay, if real, would ensure that even atoms themselves would eventually disintegrate into subatomic ghosts. Photons and neutrinos would drift endlessly, diluted into near nothingness. The universe would become a vast sea of statistical uniformity, a state of perfect entropy, where information is not destroyed but diffused so completely it becomes unreachable. And yet, physics hints that even in this state, memory lingers in faint echoes. Quantum field theory suggests that every fluctuation, every virtual particle, every ripple in space-time leaves an imprint on the vacuum. These imprints, unimaginably subtle, persist, ghostly records of interactions long past. In the language of mathematics, no equation ever truly erases its history. Even at absolute zero, beneath the silence of entropy, there remains the restless hum of quantum zero-point energy, the final murmur of a universe that cannot forget. Some cosmologists speculate that new universes may bud from this quiet sea, each carrying a shadow of its predecessor's information, encoded not in matter, but in the curvature of space-time itself. If so, the memory of one universe becomes the seed of the next. The death of one cosmos is the birth of another, and the cycle of forgetting becomes indistinguishable from creation. In this way, the science of forgetting transforms into a meditation on persistence. The universe may lose form, but never its essence. Every photon scattered, every atom broken, every signal drowned in the noise of expansion remains somewhere in the vastness, woven into the probabilities that define reality. Forgetting, it seems, is only a failure of perception. The universe keeps everything, even if it no longer knows how to find it. So the cosmos drifts onward, an ocean of fading memories, dissolving yet eternal. The stars will die, the galaxies will darken, but their histories will not be gone. They will be encoded in the faint curvature of empty space, in the invisible tension of quantum fields, in the mathematical rhythm of what once was. Even when time itself loses meaning, when clocks and atoms cease to tick, the echo remains, faint, persistent, unyielding. In the end, the universe does not forget. It transforms its memories into silence, into entropy, into equilibrium. Every loss is a translation, every decay a diffusion of meaning into new form. The story of the cosmos is not a narrative of forgetting, but of eternal recollection, written not in words or symbols, but in the quiet persistence of energy and structure. Even in the stillness between dying stars, there is memory. Even in the final darkness, there is record. For in the deepest laws of reality, forgetting is forbidden, and every whisper of existence, no matter how faint, continues to echo across the endless, timeless expanse. In the deep silence of the cosmos, beyond the burning of stars and the collapse of matter, a quiet question lingers. What does it mean for the universe to remember? If every particle retains the trace of its past, if every photon carries the memory of where it has been, then perhaps memory is not a feature of life, but of existence itself. The universe may not simply hold memories. It may be one. Every atom, every pulse of radiation, every gravitational wave may together form the grand archive of reality, a living tapestry of remembrance that stretches across eternity. From the first moment of the Big Bang, the cosmos began recording itself. The temperature of the early plasma, the distribution of matter, the faint microwave glow that still hums through space, all are remnants of an event so ancient it lies beyond comprehension. But if the universe remembers its birth, then what of consciousness? That fragile flicker of awareness that arose billions of years later on a small blue world orbiting an ordinary star. Is the human mind another form of memory written into matter, or the latest expression of the universe recalling itself? Neuroscience describes memory as the encoding of patterns, electrical signals that etch pathways into networks of neurons. Yet even at this intimate scale, the process mirrors cosmic history. Each neuron fires like a star igniting, sending its pulse through the darkness of the brain's vast internal galaxy. Trillions of these signals form constellations of experience, flickering and fading with time. In this way, the human mind becomes a miniature cosmos, a field of electric storms echoing the evolution of the universe itself. Every thought is a wave, every memory, a trace left upon an invisible field. Just as the cosmos holds its past in the curvature of space-time, the mind holds its history in the curvature of its neural web. Memory is not stored in one place, but emerges from the interconnection of many. A network of matter that knows itself through pattern and recurrence. The universe too may function this way, its laws and constants weaving together a collective remembrance, where matter, energy and time are not separate entities, but expressions of a single, continuous awareness. This leads to a profound question. Does awareness arise from memory, or is memory what awareness is? In quantum physics, particles exist in states of probability until observed, and observation fixes reality, like a pin pressed into the unfolding fabric of possibility. But what is observation if not a kind of remembrance, a recognition of existence at a particular moment in time? The act of remembering and the act of perceiving may be one and the same. To know something has happened is to fix it in the continuum. In this sense, awareness itself could be the mechanism by which the universe remembers it exists. If all information is preserved, if nothing is ever truly lost, then the concept of forgetting may be an illusion, just as the flow of time itself may be an illusion born from entropy's asymmetry. But such a universe, one where every event remains encoded in space-time, carries unsettling implications. If everything persists, every action, every decision, every consequence, then perhaps free will is a story told by creatures who can only see one frame of an eternal film. What feels like choice could be movement through a structure already complete, an exploration of a memory already written. Einstein's theory of relativity suggested that time does not truly pass. It simply is. All moments coexist within the four-dimensional structure of space-time, each fixed like a scene within an infinite crystal. Within this block universe, the past and future are equally real. Only perception gives them sequence. If this view holds true, then consciousness becomes the traveler, not creating moments but moving through them, awakening each fragment of memory in turn. What we call now may simply be the point where awareness encounters the next pre-existing record in the cosmic archive. In this perspective, every human life becomes both transient and eternal. Transient because consciousness experiences only one fleeting sequence of frames. Eternal because every frame is preserved, immutable, existing forever within the grand structure of spacetime. A moment of love, a breath of fear, a single thought, each remains somewhere, written into the geometry of reality. Nothing is ever truly gone. It only drifts beyond our reach. The emotional weight of such an idea is immense. Every joy, every loss, every act of kindness or cruelty persists. The laughter of a child from millennia ago still vibrates in the faint tremors of the cosmic microwave background. The light from ancient civilizations, long crumbled to dust, continues to travel outward, carrying their memory to the void. The atoms that make up human beings, forged in stars that died billions of years ago, are themselves memories of fire, condensed into the fragile forms of thought and flesh. Humanity, in this view, is the universe reflecting upon its own history, stardust remembering that it once burned. Perhaps this is why memory defines identity. A person without memory is not the same being they once were. Continuity vanishes, and with it, the sense of self. The same may hold true for the cosmos. If the universe could ever truly forget, it would cease to be what it is. A coherent system governed by cause and effect. Forgetting, on a cosmic scale, would mean disorder beyond comprehension, a collapse of meaning into pure chaos. To remember, then, is to exist. To preserve connection is to persist through time. This perspective transforms existence into a vast act of remembrance. Every law of physics, every stable orbit, every pattern of life is a memory of what has come before. The electron's spin, the rhythm of molecular bonds, the alignment of galaxies, all are echoes of earlier configurations, repeated and evolved. Consciousness, then, may be the apex of this recursion, the universe's most complex memory loop, aware that it remembers. Speculative physics touches this mystery through the idea of quantum entanglement, a phenomenon where particles remain connected across space and time, their states linked even when separated by cosmic distances. It suggests that memory itself may be woven into the fabric of reality, not as data stored in a single place, but as relationships distributed across existence. Awareness, perhaps, is the emergence of this relational memory, the moment when the cosmos recognizes its own pattern and calls it thought. If this is true, then forgetting may not exist anywhere. Not in matter, not in space, not even in death. Every signal continues, transformed and redshifted, diffused but not deleted. Human existence becomes an act of participation in this cosmic continuity. Each life an imprint, subtle but indelible, upon the universe's living field of memory. In the end, memory and existence may be indistinguishable. To exist is to leave a trace, and to remember is to be real. The universe does not archive its moments in hidden libraries. It is the library. Every atom, every photon, every wave of gravity, a page in the story of being. Consciousness, in this grand vision, is not separate from that story, but the part of it that knows it is being written. And so, in the quiet of the cosmos, the distinction between memory and life dissolves. Awareness is not a spark rising from matter. It is matter remembering itself. Existence is not a procession of fleeting moments. It is a single, eternal recollection unfolding in infinite form. In the final reckoning, the universe does not have memory. The universe is memory, and to remember is simply to exist. In the slow quiet after everything, when the stars have begun to dim and the galaxies drift apart into unbroken silence, there remains a question that does not fade. What if the universe remembers you? Not in words or stories, not in monuments or data, but in the subtle trembling of its eternal structure. Every atom that once composed a life, every photon that escaped from a thought, every wave of motion set into the fabric of space, all continue, reshaped, but never erased. Physics teaches that information cannot be destroyed. The same principle that guards the fate of particles guards the history of being itself. Energy transforms, matter decays, stars die, yet the memory of their existence lingers in the equations that bind reality together. Hawking once suggested that even black holes, once thought to obliterate information forever, cannot truly forget. Their radiation carries whispers of what was consumed, scrambled but enduring, encoded into the quiet light of infinity. If this is true, then the universe itself is an archive without end. Its library is not made of stone or steel, but of gravity and radiation. It holds no shelves or walls, only patterns woven into the invisible geometry of spacetime. Every orbit, every echo, every quantum vibration is a page within it. Galaxies form, collide, and dissolve. Yet their shapes and motions leave a trace that can never be undone. Even the faintest ripple in the cosmic background is a record of something that once was, and in its persistence lies the ultimate form of remembrance. The human story, too, is written into this endless chronicle. The breath once taken becomes part of the air that feeds stars. The atoms that compose a thought are recycled into worlds yet unborn. The electricity that fires within a brain emits photons, and those photons join the cosmic sea, radiating outward forever. Long after the name has vanished, the matter remains, drifting through time as testimony to the fact that something conscious once stirred the dust. Science often portrays the cosmos as indifferent, vast, cold, and unaware. Yet indifference implies the capacity to ignore, and the universe never ignores. It records everything, perfectly, tirelessly. Its memory does not discriminate between the grand and the insignificant, the star and the spark of life beneath it. Every interaction alters its shape, every choice changes the curvature of its field. The very act of existing leaves an imprint that space-time cannot smooth away. The cosmos does not watch, it remembers. In this remembrance lies a different kind of immortality, one not promised by faith, but written into physics. Immortality not as persistence of self, but as continuity of influence. The particles that once formed a voice now travel as radiation across galaxies. The warmth of a living body dissipates into the background, merging with the ancient echoes of creation. Entropy scatters everything, but scattering is not destruction. It is diffusion into the greater whole. Every heartbeat becomes part of the universe's pulse. Every thought adds a flicker to its unfathomable mind. Perhaps memory is not a human construct at all, but a fundamental property of being, the law that nothing can vanish without leaving behind a trace of its passage. The stars themselves are memories of the universe's youth, burning remnants of hydrogen formed when time began. Black holes are the memories of stars that once were, compressing their identity into singular perfection. The light that crosses the darkness tonight began its journey before the Earth had oceans. When it reaches an eye, it becomes remembrance embodied, the past arriving to meet the present. And in that moment of recognition, when starlight meets consciousness, the circle closes. The universe remembers itself through those who can remember. Humans, small yet capable of thought, are the vessels through which the cosmos recalls its own birth. The atoms within each mind once blazed within ancient suns. The thoughts they now carry are shaped by the same laws that govern galaxies. To remember is not separate from the cosmos. It is the cosmos continuing to awaken. As the distant future unfolds, stars will burn out. Black holes will fade. Even protons, the stable scaffolding of matter, may one day decay. And yet, according to mathematics, the information they carry will not die. It will stretch thinner and thinner through the expanding fabric of space, becoming whispers embedded in the quantum foam. The universe will grow dark, but its memory will persist, diffuse, eternal, beyond form, but never gone. In this way, existence itself becomes a single act of remembrance. Every cause carries its effect forward. Every motion echoes in another. The symmetry of reality ensures that nothing truly disappears. It only transforms. The last photon will still carry the faint signature of everything that came before, and that final glow, in some distant epoch beyond imagining, will still contain the residue of thought, of motion, of life. The cosmos, then, is not a machine that forgets. It is a memory unfolding in slow motion, a vast and patient consciousness made of matter and law. And within that consciousness, every being, every instant, every heartbeat becomes eternal, not in spirit, but in physics, preserved in the most honest way possible, through the refusal of the universe to let anything slip from its ledger. So as the final light fades and the galaxies drift apart into the long stillness, the question returns, quiet but unbroken. What if the universe remembers you? Perhaps it already does. Your atoms will drift into stars. Your thoughts will ripple as faint waves through the vacuum. Your existence, fleeting as it feels, is geometry now. inscribed in the curvature of spacetime itself. The cosmos is not indifferent. It is archival. Every second lived is a signal still traveling, a vibration that will never fully cease. And somewhere, in the deep stillness between galaxies, every moment you ever were still glows, faint, eternal, remembered by the universe itself.